Welcome to Silverstone Technology Cluster's Ask the Expert podcast. Today's episode is proudly brought to you by TC Group. I'm your host, Jeannie, and we are joined by Alan College. Alan is here from Lithium Battery Recycling Solutions, which is a business unit of Cawleys. Thank you for being here with us today, Alan.
My pleasure, and thank you very much for inviting me. I did actually check. We've been STC members for about 3 years, I think now. So, but it feels good to be part of that community with the technology and the engineers and things like that. So, no, happy to support.
Brilliant. So let's start by getting to know you a little bit better. Tell me a little bit about your background and how you entered the world of lithium battery recycling.
Long story or short story? Let's go for the short story. I've been in the waste industry for 30 years, and when I started, I had hair. But I joined Cawleys about 21 years ago and headed up the hazardous waste division. And then lithium batteries fell on my lap around 2012. That was the first time we had something from the battery from an automotive source. I thought it was going to be an easy thing because I was dealing with some other nasties and chemical wastes, but then found out it was really difficult. So I guess where we have got to where we are today has been a sort of a journey from those early times with a lithium battery, trying to find a disposal route, trying to find what you can actually do, and then realizing that not many people were talking about lithium batteries. And I'm going back to 2016 and 17, and then having the buy-in from the company when we actually went, maybe we need to be doing some more about this. So that's the sort of like the journey into it, a little bit by accident, as most things tend to be. But happy to sort of see the successes and how we've moved over the past, say, 7 years.
Brilliant. And so, can all lithium batteries be recycled?
It's a great question. In regards to can they be recycled, all batteries should be recycled. We live and breathe under a battery directive where there is legislation in place that when someone actually builds or makes a battery, then it has to be recyclable. So that's the rules that we live in Europe and that battery directive. In practice, no, lithium batteries are very recyclable. They're difficult, but the materials within can be recovered. So, currently speaking, we're heading towards about 80% of the battery being able to be recovered from a cell point of view. When it comes to the sort of the latter stages, which I dare say we'll discuss later on the hydrometallurgical side, we're talking sort of high 90s% of being able to recover some of the precious materials that are within.
Okay, so where do you see lithium battery recycling sitting within the rest of the UK and the world's recycling mission?
To be fair, I think it's very important. The recycling side of things fits into the narrative currently with electrification. We're moving on. We've got more challenges of going to zero CO2s and things, and electric vehicles, zero tailpipe emissions, and all the rest of it is very attractive to that. But in regards to building something which it needs a lot of CO2 to build it in the first place, the upshot is that you need to have circular economy. You need to be able to turn around and say, look, here we have, for instance, EV cars or battery electrification, but we've got to have the backup of being able to recover those materials sustainably, so that we can carry on making more batteries there ongoing. And I think that's a very important point, considering that if you take cars, for instance, there is we're up in the air with cars. There's more people in the country that don't drive EV cars, and if you read the media and the social media, then we tend to have some form of negativity towards the cars and the adoption and the legislation changes. So I get to hear things like lithium batteries are toxic waste, they go in landfills. I even heard that some people are dumping them in the sea, and these are all complete untruths, because actually that's illegal for us to do that. So it plays a very important part of the sustainability of electrification, because you can't have all the good news of lithium batteries and saving the planet and CO2 reduction and things on one side, and then have this lump of power which is you can't do anything with. We need to be able to recycle that.
That brings me really nicely into my next question. So there is such a strong narrative surrounding batteries being recycled separately in general. Can you tell us a little bit about the dangers around recycling lithium batteries?
Yes, yeah, I can. There are many. I suppose when when it comes to the batteries, then the most common thing that people think of is fire. Lithium batteries are a fairly special thing in as much as they give all three things in the fire triangle, if you know that. So they are their own fuel, they can develop their own oxygen, and they can give themselves their own heat. So actually, to be fair, they're very difficult fires to put out. But that's when obviously things go wrong and laws of physics are in action. Essentially, if you've got kilowatts of energy inside a battery being stored, when it is abused or damaged, then it's going to want to come out as heat and light, and that's where the sort of intense fires come from. Moving on from that, from a recycling point of view, electrocution is a high risk. More so on the batteries that we do on the larger side. So EV batteries, FEVs, BEVs. We're dealing with car batteries which are 800-volt powertrains. It is DC voltage, sticky voltage. It's pretty dangerous in as much as all it takes is 150 milliamps of current or DC current to upset your cardiac rhythm. With a car battery, you can have thousands of amps because it's designed to obviously launch a car in 3 seconds or whatever. It's got real high power demand. But what that means is, of course, that when we open the battery cases up, we're exposed to high voltage, and if you were to touch the wrong place, it's immediate lights out. You will be frazzled. It's dead. So obviously we take extreme care when we're dealing with the batteries. There's a lot of competency training that's involved, and actually the PPE and the equipment that we use is all insulated and keeps our trained guys safe. Further to that, we're dealing with the chemicals inside. So we're dealing with some some nasties in there. In the electrolyte, ethylene carbonate, diethylene carbonates, you've got lithium hexafluorophosphate. There's some fairly nasty sort of chemicals within the electrolyte side of things, along with obviously some toxic metals like cobalts, nickels, and the like. So we have to be careful of that. Our process, from a shredding point of view, creates a dust, and of course that is that we wouldn't want to be breathing any of that in. So we take that control very, very seriously to contain all of those sort of chemistry type exposures, and then perhaps something that don't really sort of think about, but they're big and cumbersome. The batteries themselves, we could be talking 600, 700, 800 kilos. In some commercial vehicles, they're even larger than that. And of course, if you're moving them around, then you certainly will want one of those dropped on your foot, even if you were wearing a steel toe cap.
So you talked a little bit about your process. Can you tell us what the end-to-end process is of recycling a lithium battery, and how long does it generally take?
Yeah, sure. I would say that the process that we have, we kind of sort of see it in 4 stages. So the first stage would be I say simple, but actually dirty job of collecting the batteries themselves. This is something that's highly regulated. They are a dangerous good, and some of the difficult, damaged batteries that we have, we really have to sort of take care of the collection to make sure that we're not having sort of thermal incidents on the way, for collecting the battery coming from the battery producer and to us. We have some very strict protocols in dealing with damaged defective batteries. We need to know what they are and that beforehand, so that we can give our experience and provide the right packaging, so UN approved packaging, and the right paperwork and the right sort of qualified drivers to sort of pick those up. But so that does actually form a real big part of the job, because it's a bit like risk management. We're trying to make sure that things are safe for our clients and for us. But yeah, so we pick the batteries up. They come into us, and we have a discharge array. So we do a DC to AC conversion, and we harvest the energy coming out of the batteries. But once that battery is dead, once the battery, then, you know, as we said about the risks earlier, then the electrocution risk is gone, and actually the fire risk is gone, because the energy that's used that could create its self-heating is now gone. But once that battery is discharged, it can be disassembled. I mean, most of the batteries we have are a bit like Russian dolls. You have a big pack, then that is made out of modules inside, and then the modules themselves are made of a collection of cells. But we go to a modular level, and then we shred. And the shred is the stage 2. So stage 1 is where we're handling a battery, even when it's still discharged. Stage 2 is when we shred. And that's a bit anticlimactic, because the batteries go in one end and it comes out as a collection of mixed solid material, which we call a lithium flake. Because it's a bit like a dry sort of flake, but it is all of the solids of the batteries sort of, you know, being mechanically separated at that point. Stage 3 is the separation of that mixed lithium flake, and there is various techniques in doing that, where we've got density filtration, we've got cyclone extractions, and we've got filters and sieves, essentially, to be able to screen off the solid content in the battery, which would include you know, hard metals, case metals, you know, chunks of aluminium and copper, plastic, which is in the plastic separator, aluminium and copper, which are the foils on the anode and cathode, and then the term that everyone sort of leans to is black mass. And black mass is a kind of a colloquial term to describe the coatings which are on the anode and cathode, and this is where you start seeing you know, nickel, cobalt, manganese, lithium, all of the emotive sort of rare earths and minerals, which we're trying to obviously get that extracted. The stage 4 after that separation is essentially refinement. Is where you take those individual separately collected fractions and you refine them back into new raw materials. So in the process for, you know, coppers and aluminiums, you can probably understand there's a fairly direct route with metal recycling and recovery in the UK and beyond. But the black mass that we separate, that has to have a metallurgical treatment, a hydrometallurgical treatment process, which is then to do the separation bit, so we can get something usable at the end of it, normally a CAM or PCAM, to be able to be used into new coatings on new batteries.
Okay, wow, that sounds really interesting, actually.
I did that all in one go. Yeah,
you did. Yeah. Well done.
In regards to sorry, you mentioned, sorry, I forgot your question. You mentioned about how long it takes. I mean, invariably, you know, our process takes us to, so, you know, part of those stages. The actual full stages of going from, you know, a battery through to being made into something that's now going to be classed as raw materials actually could take many weeks, because we don't have hydrometallurgical treatment in the UK commercially available yet. So we're having to, you know, export our materials out, so it can take, you know, a number of days to reach, you know, to another part of the process. So but when it comes to having the batteries collected and doing the discharge and the disassembly and the shredding side, actually that's fairly swift. You know, we can do that within a couple of days as such. So that's not too much of a problem. But we do look forward to the day, you know, where, you know, we've got all of those stages within the UK, which will help keep costs down and travel and transport and such things.
Yes. So what are the costs? You've just touched on costs there. What are the costs associated with recycling, and where do they mainly come from?
So what I would say is that costs at the moment are fairly dynamic. You know, we really haven't found the best ways of dealing with lithium batteries, you know, ongoing. I mean, if you think that we're probably within the first 10 years of dealing with lithium batteries, and then compare it against, say, lead acid batteries, where we're 160 years better practiced, you know, we're just finding out what the best ways forward are. So because it's a kind of a movable object, actually the cost wise is pretty difficult to contain. The other side that we have, which is I guess some of the problems we face, is low volume of batteries. So of course, all of the things that we're doing and have done for the past 7 years has been a touch R&D. We're trying to sort of negotiate our way through all of the different technologies that you can have to do the battery recycling, all the equipment levels that are there. And in fact, the equipment that we can buy today, some of it is actually completely different to what was available on the market even 12 months ago. And then have a look at the great work which the UK universities and research establishments are doing in regard to battery recycling, and they're looking forward as to where this all goes. It's difficult to sort of do the costings, I suppose, when things are just being moved quite a bit. What I can say is that what we do is we judge things on the here and now. So I mean, I'm a cost, my business is a cost, my operatives are a cost. So we the licensing and the permissions that we have are a cost. And when you're dividing those collection of fixed costs against only so many batteries coming in, things tend to be costly. The other thing that we can't escape out of is the fact that we are a single source site in the UK, and that means that when we're doing haulage of batteries, then we are bringing them, in quite far distances. We'll be bringing them from the north of Scotland, from Northern Ireland, from the south coast, and the transportation of bringing batteries back to us, and especially dangerous goods transport and ADR transport, is pretty costly. So things that we can't get away from is geography. But as we move on, expanding the facilities into multiples, waste doesn't normally travel. We're based in Luton, and there's a reason why we don't collect waste in skips and wheelie bins in Liverpool, because that wouldn't make sense. So when it comes to the batteries, we've got to sort of follow that trope, and in particular probably the sort of the hub kind of mentality of having a regional player being able to take batteries in and recycle it is where it will follow, and that will reduce the cost down. When it comes to the processing, as I touched on earlier, we export. I'm sending mine to the North Europe, and when we're filling containers and going on a ship and it takes 5 days to get there, things are costly. I suppose putting all of those together, when it comes to the cost, things are quite high at the moment, but we do foresee that when we have volume, and when we have greater amounts of process, especially things developed in the UK or even France, then it will be a little bit more under control, and we could see quite easily where we could get from being a cost model to cost neutrality, or even a rebate basis for lithium batteries eventually.
Wow. So looking to the future now, because you've touched on that, you've talked about some of the challenges, geographically, and the fact that you are a single site. What are the other challenges that you see facing you within the sector and as a business?
I'd say the challenges for me is one of timing. We're already developing our next workshops, so we're at version 1.0, and now we need to get to version 2. So the challenges are seeing the technology and the processing, the plant that's available now, and putting it all together to see what would be the best, most efficient, cost-effective way of recycling the batteries. So the challenges are one of doing that while the market is still a little bit unsteady. Even sort of up to a few months ago, the ban on internal combustion engines, is it going to be 2030? Is it 2035? The cost of the electric vehicles versus petrol and diesel, the the growing infrastructure on charging and all this kind of thing, there are some worries for the greater part of adoption of electric cars. And right now we've got the best part of for a few million or whatever it is of cars on the road, 1.3 I think it is, but we calculate that to be something like 440,000 tons of lithium batteries. One day they're going to be a waste. One day we're going to need to deal with them. But for the meantime, the biggest, I suppose, question for us is that feedstock of when it's going to come through. You can still buy cars that were lithium battery powered from 2011 to 13, the first sort of batch, so to speak. You can still buy them on Auto Trader. So we haven't yet reached that kind of banger status of the cars being thoroughly made redundant and then falling off the chain and then going through the vehicle recyclers. And I guess that's to be expected, in as much as most cars today, you're looking at an old petrol diesel car. Probably the reason that they will be scrapped is because they've broke down. We don't build cars these days that are complete rust buckets, like an old Ford Cortina or a Capri or something like that. Sorry to blame on poor old Ford. I'm sure Vauxhalls were the same. But the upshot of it is that those cars, a clutch breaks down, or a turbo goes, or a gearbox goes, a head gasket goes. Some of the repair bills for those early cars is just too much, so the car gets scrapped. When it comes to an EV car, there's less moving parts, but by quite a quantity. So it either works or it doesn't. And then the focus is on the battery degradation and how far it can go. So these are all things that we've got to probably grow into certainly in the next 5-10 years, to be able to establish how long the cars are going to last, because we are in these early generation stages, and that knowledge really isn't there. So the cars are kind of lasting longer. We are growing from a electric car point of view, but most of it has been fleet. Most of it has been adopted by company cars and things. But when those cars reach through the second-hand markets as such, and fall off the end, that is where we would probably end up seeing that true volume of retired batteries. And we may be some way off. So big challenge for us is where we go from an investment point of view, what plans and things to be efficient, but also with a keen eye to finding out where the batteries are coming from.
What is the future of lithium battery recycling? Do you see more happening here in the UK, less export? What does it look like moving forward?
I would say that what it looks like is that we will grow to embrace scale. So at the moment, we're in the hundreds of tons. We now need to get to the thousands of tons. And what does a lithium battery recycling plant look like for that? And in that regards, there's great thoughts into how that can be achieved. Right now it's a very manual process for us to take an automotive battery and have our qualified electricians to take it apart and do all of that. But with between two guys qualified, we're only doing something like 3, 4, or maybe 5 batteries a day. But what happens when I need to get to 50 batteries a day? So the thought is that we probably don't really want to be thinking about going 10 times the manual personnel route, but maybe some form of automation and robotics could help. Could we get to a stage where the batteries are made in a robotic production line, but how about something that's in reverse? And there could be machinery and things, and I am aware that universities and some research establishments are on that pathway. They're looking at doing robotics. I've seen some of the work, and there's some very good work going on. But where we need to get to is that a battery that's waste goes on a conveyor belt, and good robots take it apart in a far quicker and safer time than humans. So does future look a bit more technical for lithium batteries, and does it look a bit more clever? So that's one thing to think about. The other side for the future is how it would be good if we could steer the design of batteries. So one of the problems with robotics is the challenge that a Nissan battery is made in a Nissan factory with a Nissan robot. A Tesla battery is made in a Tesla factory with a Tesla robot. But if I need to have a recycling process where I'm doing a Tesla, Nissan, BMW, Mercedes, Porsche, VW, I've got to have a robot which is the equivalent of a Swiss Army knife. It's got to be able to deal with a multitude of different fasteners, a different set of designs, and AI, clever eyes, and things like that, which can detect, are all technologies that are I've seen in development. But when you're dealing with that dirty battery that's been underneath a car, and the fasteners are all covered with a weatherproofing sealant, then things get a little bit more difficult to go and do that. So when it comes to the standards, there is no standardization, so it makes that robot disassembly pretty difficult. The other thing for me on the discharge, because our technology is based on discharging the batteries wholly, we have to kind of break into that battery to bypass BMS, the battery management system that keeps the battery healthy. We have to, in short, try and get to the positive and negative of the battery to do that discharge. And that can be exposing the battery to high voltage, and we touched on how dangerous that was earlier. And with standardization, I would love it if we had a plug, like a proprietary plug, which was the same on every single battery pack, where we could just plug in, and we could tell that the battery was ready to be killed off, in a sense, and go against its programming to protect itself, and then give us an ability to discharge it safely as a pack whole as such. So maybe the future needs to be thinking about battery design in the future. We're looking to make the recovery recycling process easier, but I think we're a way off from there, because most manufacturers are pretty much doing battery development to be the best that they build a best battery they can, energy density, performance, lightweights, and or materials and things. They're just trying to build the best battery they can. So I think we're a way off from being able to sort of point them in the direction to help me as a recycler.
Okay, so I think that's all for us, Alan.
Okay. Yep.
Thank you so much for being here and sharing your insights with us. It's been really interesting and enlightening, and hopefully we can have you back again soon. You can tell us a little bit more about the process. We can talk a little bit more about changes that are happening and different things that are maybe on the horizon.
Yeah, no, I'd love to explain all of that. So no, thank you for inviting me on the podcast.
That's great. And to everyone listening or watching, thanks for tuning in. Be sure to subscribe to the STC's podcast and stay tuned for our future episodes. Thank you, Alan.
No problem. Thank you, Jeannie. Bye.